Tuesday, we were speaking about whether it is a function, whether a graph is a function or not. So today what I wanted us to do is just move on from that point and start talking about the inverses of one-to-one linear functions. These are generally not tested in exams, but it is an important place for us to start and for us to begin to understand what we're doing when we're actually performing an inverse. Okay, so that being said, let's just define what we mean by an inverse, right? So when we are talking about an inverse function, right, we can look at it in one of two ways. So either you can regard an inverse as the interchanging or swapping of x and y. So what I've done is I have swapped x and y. All right. So in other words, I'm changing around output and input. So output becomes input and vice versa. Is one way to look at it. Or the other way of us looking at an inverse is that it is a reflection. And it's a reflection over a very special line. Okay, it's a reflection over the line y equals x. Okay, so in the beginning, it's a bit difficult for us to understand what is this line y equals x and what does it mean? Well, it is a horizontal line, okay, it's diagonal, and the line y equals x means y equals 1x plus 0. So we all know in maths, we don't ever write plus 0, and we also don't write ones. Okay, so if we write x, we mean just 1x like that. So in other words, if that is my Cartesian plane, there's my x-axis, there's my y-axis. The line y equals x is a diagonal line that goes through the origin, and it has a gradient of 1. So that is the line that I'm talking about, that the reflection takes place over. So let's jump in and use the rule f of x equals 2x minus 4. So f of x equals 2x minus 4 is my original function. And I can write it using functional notation because it is a function. It is a one-to-one function. When I want to interchange x and y and determine the equation of the inverse, what I'm going to do is first write f of x as y equals 2x minus 4. Now I'm going to do my swapping. So what was x becomes y, and what was y becomes x. So I'm going to say x equals 2y minus 4. And now I have to define my function in terms of y, which means I need to make y the subject of the formula. All right. So if I leave 2y on the right-hand side and I take the 4 over to the other side, I would end up with 2y equals x plus 4. So now dividing through by 2, I would end up with y equals x plus 4 over 2. This can also be written as y equals half x plus 2. Or if you wanted to, you could also write it as y equals x over 2 plus 2 is 2 like that. It all means the same thing. Okay. Is everybody happy with that so far? Oh, sorry, one last thing that I want to say. And now what I would do is I would write it using my inverse notation. So f to the minus 1x equals, and I prefer to write it like this, but if you want to write it in this format over here where I put the little green star, there's absolutely nothing wrong with that. Before I take any questions, I just want to point out that this is the notation that we use for inverse functions. Okay, so that minus 1 there is a symbol. Okay, it does not mean the same thing as when we're working with exponents. Okay, so it's not the same thing. It's just a symbol. So if I write 2 to the power of minus 1, then I'm talking about 1 over 2. Or if I write 5 to the power of minus 1, then I'm writing 1 over 5. It's not this. Okay, so the minus 1 is just a symbol that we use to show that this is now the inverse of f. Okay, Amina, what's your question?
Hi, ma'am. Okay, so I wanted to know, sorry, The sign as negative will also change. So if it's negative, it will become a positive. If it's positive, it will become a negative.
In relation to what, Amina, are you asking me that?
Well, is it normal like every sum that we get? Like, see, this one was -4, it became a positive. So does that
Oh, okay. All right. I see what it is you're saying. Yes, that's going to happen because whatever your C value is, it's going to go over the equal sign. So it's going to end up changing its sign. So let's have a look at another one, for example. Let's take the line y equals, let's change the sign of the gradient and let's change the sign of the y-intercept. Okay, so there we've done opposite gradient and a positive y-intercept instead of a negative one. So now if I do the inverse of this, I would say x equals -3y plus 1. So now, Amina, I'm going to take that -3y over to this side just so that I'm working with a positive. And now look, my x is negative. Okay, and then I'm going to divide through by 3. So y would be equal to -1/3x plus 1/3. So yes, it's changed its sign. Okay, are you happy with that? The gradient is still negative, but yes, the y-intercept has changed its sign, yes.
Yes, ma'am, I get it now.
Okay, cool, no problem. All right, so that was just another example that I just made up on the spot just to help Amina understand that. Okay, so let's just get done here. All right, so now the next thing that we need to be able to do once we have determined the equation of the inverse is that we need to be able to sketch our functions. Now, when it comes to a function like y equals 2x minus 4 and y equals x plus 4/2, what's nice about these particular graphs is that they don't go through the origin. When graphs go through the origin, it becomes a little bit more difficult to draw them. But let's just start here. And I do have questions that go through the origin that we're going to have a look at. What do we need when we want to draw a straight line? When we want to draw a straight line graph on the Cartesian plane, there's something that we need to be able to do that. Right. Does anybody know what that is? What do I need? Katleho, what do I need?
Ma'am, I was going to say the equation, but then people say the gradient, so I'm no longer sure. I'm not confident of what I'm saying.
Okay, so if you have a look, you've got the gradient, all right? But if you have a look at some of the other things that people are saying, so aware 2 is saying the coordinates, Amina is saying the x and y intercepts, and they are both correct. Okay, absolutely. Tiamo also the intercepts. Yanela, the intercepts. Absolutely. Okay, so literally what you need is any 2 points on the graph. Okay, so in order to be able to draw any straight line function and or its inverse, you need 2 pairs of coordinates. So either they can be in the form of the intercepts, or it can be any 2 points that lie on both functions. Okay, that's what you need to be able to draw a straight line. So in this case here, we're going to work with the x and y intercepts. So let's first consider the line y equals 2x minus 4. Can anyone tell me straight away, what are the coordinates of the y-intercept? What are the coordinates of the y-intercept? Do I need to calculate them? Or is there a shortcut I can take here? What are the coordinates of the y-intercept? Anybody know? Not negative. So Yanela, you're correct. Penga, yes. Asanele, sorry. Yes. Good. Pegelo, quite right. Shisana, lovely, 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 lovely. Perfect. So the coordinates of the y-intercept would be 0 and -4. I can read that straight from the equation, because remember, this value over here is my y-intercept. Okay, so I've got that. In order to get my x-intercept, I need to let y be equal to 0. So that's not a difficult thing for me to do. So 0 equals 2x minus 4. That means that 2x would be equal to 4. Divide both sides by 2. So x would be equal to 2. So the coordinates of the x-intercept would be 2 and 0. So now I can go ahead and sketch this line now that I've got these 2 points. So there is 2 and 0 over here. -4 is a little bit further down. It's over there. And now that I've drawn those those 2 points on my graph, I can now get a ruler and connect the line, connect the dots. Okay, so I can do that. Okay, so I've plotted both of these points, drawn my line, and I've labeled it. Okay, I want to do the same thing with y equals x plus 4 over 2, right? This is why I think it's nice to write that, instead of writing it as y equals x plus 4 over 2, I prefer to write it as 1 over 2x plus 2, because then I can clearly see what my y-intercept is. All right, so similarly, the coordinates at my y-intercept, I can read straight off, and that would be 0 and 2. Okay, I want to again find my x-intercept, let y be equal to 0. Take my 2 over to the other side. And now to get rid of that half, I'm going to times both sides by 2. So x would be equal to -4. I want to point out something to you, but I'm just going to sketch this graph first. So there is my x-intercept at -4 and 0. So that is this point over here, 0 and 2, that point over there. Let's just highlight them in green as well. Grab a ruler, connect the dots. Label my line. Okay, the other thing that is also important for me to show in this case is the line over which my reflection is taking place. Okay, so here it is in pink. Okay, there is y equals x. Okay, so the green line is the reflection of the yellow line over the pink line. Okay, now there is one more thing that I want to point out to you, but I just want to take some questions before I do that. Okay, so Pinga, ma'am, yes, absolutely. So Pinga, you're going to do one like that, or I can do one like that with you, and then you can try one. Maybe we should do that. Okay, so Amina, y plus x is not anything. Okay, so y plus x is not a function. It doesn't have any meaning in this. It's y equals x. Or is that what you're asking me? Are you asking me what is y equals x? Okay, so y equals x is the line over which this reflection was taking place. Remember in the beginning over here, I said to you, we can either look at an inverse as though we are swapping x with y, or that it is a reflection over the line y equals x. Okay, so that was what I was talking about over here, Amina. I don't know if you missed the beginning bit. All right, but over here, when I was saying the line y equals x is a horizontal line that we can draw onto the Cartesian plane that has a gradient of 1 and it goes to the origin. So the value of c is equal to 0. Okay. Yes, absolutely. Absolutely. So Segofatso, in tests and exams, they will probably more than likely, they will get you to sketch the inverse of a function. Absolutely. Okay, whatever inverse they choose to give you. All right, so either they can give you the function and then ask you questions on it, or they can get you to sketch it, but you need to be able to do both. So you've got to be able to find its equation, sketch it, and then also answer sort of application type questions as well. Okay, that's normally what we do with functions. Okay, so before I move on and I talk about what happens when it passes to the origin, I just want to point out something to you, okay? If you have a look at what I highlighted in yellow, remember, this was my y-intercept, okay? So this point over here was my y-intercept, and you guys can see it clearly down there, okay? There was my y-intercept. What was my y-intercept of my original function? Became the x-intercept of the inverse. Can you see that? Okay, so what was y is now x. Can you see how the coordinates have switched around? X and y have swapped places. Right, and it's exactly the same thing with my x coordinates, right? If you have a look here, this was my x-intercept. Okay, now it is my y-intercept on my original function. Okay, so again, if I go and point that out to you, what was my original x-intercept? Over here, 2 and 0 is now my y-intercept on the inverse. Okay, can you see how x and y have switched around? Okay, so that is the same thing as swapping x with y, and it is the same thing as reflecting the line over the line y equals x. Okay. Yes, you are supposed to, Amina, you are supposed to sketch the line y equals x. Absolutely. Okay, and it will always be the same. It'll always go through quadrant 1 and 3. It'll have a positive gradient. And essentially what it does, Amina, is it cuts quadrants 1 and 3 in half. Okay, and just cuts them in half. All right, you happy with that? Is everybody thumbs up? Are we feeling good? All right. Okay. So let's go. Nice. So let's go and have a look at a line that goes through the origin, which will be a little bit more difficult. Okay. Where to? What's your question?
Hi, ma'am. I wanted to
Hi
ask,
there.
essentially what you're saying is if we're given the coordinates for the x-axis, ma'am, if we wanted to plot the line for the y-axis, we just need to swap the coordinates around.
Correct. So in fact, if you go back here and you have a look at this, before you even work any of this out, you know what your x and y intercepts are going to be, because what was your y-intercept is now your x-intercept, and what was your x-intercept is now your y-intercept. Absolutely. Okay, the algebra just proves it, but we know that that's what's going to happen. Okay.
Thank you.
All right, no problem. Okay, so let's go back and go and consider a slightly more difficult example. So let's consider the graph f of x equals minus 3x, right? If we now, in the first instance, want to determine what the inverse is, right? I think we all know what it is that we need to do now. What we're going to do is switch x and y around. So where I had y equals minus 3x, I've now got x equals minus 3y, right? A function has to be defined in terms of y, so I need to make y the subject of the formula. So I'm going to divide by -3 on both sides. So in other words, y is going to be x over -3. Now, a better way for me to write that is as minus 1 over 3x. Okay, is everybody happy that I can define it in that way? So my gradient is still negative. Okay, so the equation of my inverse is this. Okay, swap x and y. No, I'm not sure how to say your name. Mange, is that correct? Sorry, I hope I haven't pronounced that terribly. No, it's not the same as logs. Inverses, we study logs under inverses because a log function is the inverse of an exponential function. So we're not talking about that just yet. Okay, here we're talking about the inverse of a straight line function. Okay. Yes, absolutely, Pinga. You are still writing the same thing. Yeah, 100%. Okay, but I'm just using the correct functional notation. But yes, the second to last line and the very last line are identical. I'm just repeating myself. Okay. So yeah, it's not necessary. All right. If they tell you in the form f to the minus 1x, then you should write that. Okay, but if they don't specify, then no, it's not necessary. Now, if we were to work out the coordinates of the x and the y intercepts of both our original and our inverse, we're going to have a problem in this case because my x-intercept is 0 and my y-intercept is 0, right? So algebraically, if I now take, because remember this was my original function, okay? If I work out I can see the value of c is 0, so I know that the y-intercept has the coordinates 0 and 0. But even if I tried to solve for an x-intercept and said this, I'd still end up with x equals 0. So I'd end up with that. I cannot draw a straight line with one point only. All right. So if I cannot draw a straight line with one point only, it means I need another point. Now, which point you choose to use is unimportant. All right. You know that when you are going to be sketching this graph, it has a negative gradient. So if I just do like a little mock sketch on the side over here, there are my axes. I know that the line minus 3x, oh, that is dreadful. Hold on a moment. Let's just get rid of that. Let's do this rather. I know that this line has a negative gradient. I know it goes through the origin. So it's got to look something more or less like this. Okay. So whether I choose to use negative x values and have a point that lies over here, or whether I choose to have positive x values and have a point that lies somewhere over there, it really does not matter. You could use -1, you could use -2, you could use -3, you could use -4. It doesn't matter. You could use 1, you could use 2, you could 3, you could use 4. It doesn't matter. As long as you've got 2 points. Remember, we've got the origin. So if we've got this point over here, we can connect it and we can draw a straight line. So let's say we decide that we're going to use the point -1. Okay. So in other words, I've got input, output. I'm choosing to use -1. I now want to calculate my output. So just sub it in. Y is equal to -3 times -1. And that means that this would be equal to 3. So that gives me another point. Okay, so in addition to the origin, I've now got this point over here, which I can use to plot that function with, right? What would this same coordinate on the inverse look like? Because remember, this is also going to go through 0 and 0, but it's not going to go through -1 and 3. What is this coordinate over here? So this bit over here, what point would that be on the inverse? Can anybody tell me? Yes, Pinga, it would have a positive gradient. There you go. Slender Kuhle, lovely. Shisana, 100%. Okay, so 3 and -1 Pigelo. Yeah, you just swap them around. X is Y, Y is X. Lovely. Lovely, 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 guys. That's brilliant. Okay, so now I know that this line has to go through 3 and -1, like that. Okay, now I've got to draw this. Okay, so the next step. So let me just go down a little bit. We're going to grab some axes. Okay, there we go. There's our y-axis. There's our x-axis. And what I'm going to do is I'm going to put in the line y equals x first. Okay, so it's going to look something like that. Okay, so there's the line y equals x. It's gone in. Let's draw the original function first. So the line y equals -3x. Let's draw that line first, and I'll do it. Hopefully everybody can see this. Okay. I know that it has to have a very steep gradient. Okay, because the gradient is -3. So I could make my line look like that, right? So here is the graph of f, or this was the line y equals minus 3x. Remember, I had already decided up here that it went through the coordinates minus 1 and 3. So let's say I decide that the coordinates minus 1 and 3 is that point over there. I can label it. Okay. Now I want to draw the other line. Its gradient is much, much shallower. So now let's grab some green. Let me do that. Here's the graph of the inverse, and it goes through the point 3 and minus 1. Okay, that's all you need to show. Okay, you don't need to show any more than that. All right, everybody happy with that? Okay. So is the gradient of the red line 1? Yes, Pinga. Okay, the gradient of the red line is 1. Okay, because it's an invisible 1 in front of that x. Okay, the gradient of the yellow line is minus 3. The gradient of the green line is minus 1 over 3. Okay, everybody happy? Thumbs up, thumbs down. How are we feeling? Good, Pagelo. Yes, Amina, go for it.
Oh, ma'am, why do we make it 1 over 3x?
Okay, so remember that came from us changing it around. So do you recall when I did this, there was the original function. This is when I did my swap, and this was me making y the subject. Okay, so I had to divide both sides by -3 because that was the coefficient of y. All right, so it becomes x over -3, which I can write as minus 1 over 3x. That's why it's minus 1 over 3. Are you happy, Amina?
Yes, ma'am.
Okay. Nozipo, the gradient of the line y equals x will always be 1. It will never, ever be anything other than 1. Okay, but the gradient of your other lines can obviously be different. But the line y equals x always has to have a gradient of 1. Okay, Lanky, you said, can't the line y equals x change to cut the graphs in reflection? What do you mean change?
Ma'am, I mean, that line, can it be between the inverse and the original graph?
Yes, absolutely, absolutely. And it would be if the inverse and the original graph had positive gradients. Okay, so if you have a look up here, it's in between. Okay, because those lines have a positive gradient, but the ones that we just sketched now have got a negative gradient, so it's not going to be in between. Okay. So here we were working with positive gradients. That's why it looks as though it's in between them. Whereas here, we weren't working with positive gradients. We were working with negative gradients. Okay. All right. So now let's give you guys an opportunity. So Asanele, you're saying, so is the gradient what's before x? Yes, Asanele. Yes. Okay, so the number in front of the x is your gradient of your line. Okay, how steep it is. Okay, all right, let's give you guys an opportunity to try these. Okay, so as I had shown you, sure, Nosipo, that's fine. Let me just get everybody else started and then you're welcome to ask. Right, so everybody, we're going to do question B and question E. All right, question B is like the first one, the first example we did. Question E is like the second example. All right, so I want you to determine the equation of the inverse for both, then draw them on the same set of axes, put in your line of symmetry, and then I want you to calculate the coordinates at the point of intersection. Okay, Nosipo, go for it.
Ma'am, how do you know where to plot the line -1 is to 3?
You mean the minus 1 over 3?
Yes.
Okay, so the line y equals minus 3x is going to have a very, very steep gradient. So the other line has to have a shallower gradient. So when you are doing a sketch like this, it doesn't have to be 100% absolutely perfect. It just has to be more or less correct, all right? So in other words, if my original function, let's just draw x and y. So if my original function is the line y equals minus 3x, this gradient here has to be steeper. So if I draw this line like this, okay, so I could draw it like that. But if I chose to draw this, let me just see if I can change this. I think I'll be able to. Oh, that just makes it longer. I wonder if that changes it. If I draw the line and it looked like this rather, that would also be okay. All right, just as long as it has a negative gradient. The other one as well, because the gradient is shallower, I would have to make sure that it was shallower. All right, so in other words, I would have to make sure that it looked something like that. Okay, so if I did that, that would still actually be okay. That would be fine. Okay.
Ma'am, how do you know whether the line should be steep or shallow?
Okay, so that knowledge comes from grade 10, grade 9. Okay, so in other words, the closer your gradient is to 0, the flatter the line is going to be. So if the gradient is equal to 1, then it would be like this. But if your gradient is equal to 2, then the line would be steeper. If the gradient was equal to 3, then it would be even steeper than that. Okay, and it's the same thing the other way around. So minus 3 is a very steep gradient, but if you have minus 2, it would be less steep. If you had minus 1, it would be less steep. Okay, so as this number approaches 0, the line starts to flatten out.
I understand, ma'am.
Okay, all right.
Ma'am, does it also count if the whatever that it is that we're plotting is negative? Does it become steep or does it become shallow?
Okay, so in the case of this, all right, what you would find is that your gradient becomes shallower every time. Okay, of your one-to-one functions, the gradient would become shallower
If it's
in
negative.
your inverse. Yes, no, for both. So if you have a look at this one over here, all right, your gradient was originally 2, then it was a half. Okay, so the original graph is steeper than the inverse. And the same thing with this one over here. Your original graph is steeper than your inverse. So you'll find your inverse graph will always have a shallower gradient than your original function. Okay, irrespective of whether your gradient was positive or negative. Okay. All right. Okay, so there's some nice answers coming through. Okay, sorry, Kabela, I'm going to take your question now. Let me just go back here. There we go. All right, so you guys just carry on working. So, Kabelo. Yes, absolutely. Okay, so Kabelo, yes, 100% you can do that. Okay, just to answer your question you put in the chat. Yeah, so there's E. E is f of x equals minus 2x. Slindo, let's have a look at your answers. There we go. Good. Well done. Yes. Yes. All right, so yeah, I can see a lot of you're sharing your answers, which is great. A lot of you have got correct things there. So we're going to look at the answers just now. I'll just give you another couple of minutes to finish this.
Let's go, matrix. Let's go. We can do this. Guys, please do label your work so we can see where you are.
Sure, Ola, go for it.
Afternoon, ma'am.
Afternoon, how are you?
Good and you, ma'am. Ma'am, I have a question. After drawing our graphs, right? When we labeling them, is it fine if we label them functional notation F and just F, or do we have to like write the whole equation?
No, you can use just that functional notation. So you can write F and then F to the -1.
Okay, thank you, ma'am.
No problem, no problem. So Pinker, you don't need to determine the line of symmetry. All right, so that is something that is always a given. All right, so your reflection line, your axis of symmetry, it's always going to be the line y equals x. So it's not something that needs to be determined. You just need to draw it more or less accurately. Okay, so in other words, it's got to go through the origin and it needs to cut the first and the third quadrants in half. And as long as it does that and it's got 2 arrows on the end, you're good to go. Yes, absolutely. Absolutely. So that axis of symmetry never ever changes. Okay, so Nosipo, with which one? With B or with E? Okay, lovely. So, all right, that's fine, Alungile, not a problem. All right, can both of you share on the chat the equations of your inverses that you've got? Yes, Yanela, perfect. So Alungile and Nosipo to share the equations of your inverses. So just want to make sure that that's correct before we go and sketch. Cabello, you've switched them around. Okay, so you should have Cabello. Let me just so Cabello. I'm just hang on a second. Are you giving the coordinates for the inverse? Yes. Okay, so for the inverse, yes, that's correct, Cabello. Sorry, I thought you meant for the original function. That's why I was saying no, but for the inverse, yes, that's correct. Okay, so Nosipo. Yes, that's correct. Okay, so Alungile and Nosipo. So Nosipo, you have shared with us f minus 1 of x is equal to, you've got x plus 6 over 3. Okay, so that's correct. Okay, so you've got the same thing. All right, Alungile. All right, so what's a little bit easier here is write this as y equals 1 over 3x plus 2. Okay, so now you can see what your x-intercept, what your y-intercept is and what your x-intercept is going to be, right? Remember, you need 2 points. So here you used 0 and negative 6 as your y-intercept. For your x-intercept, you had 2 and 0, right? So now, as far as the inverse is concerned, your x-intercept is going to be minus 6 and 0, and your y-intercept is going to be 0 and 2. Okay. So now you can go ahead and go and plot those points on a graph. So for example, and I will show you guys, sorry, hold on, that's the answer is looking a little bit better than this. Okay, this is just to help Alungile and Nosipo who was struggling. Okay, so if we do the original function first, okay, negative 6 would be somewhere down here, and 2 would be somewhere over there. So we can go and grab a straight line. Just, okay, so let's just, okay, so that's negative 6, and that's 2 over there. All right, let's do the same with this one over here. Let's just do it in a different color. Okay, so now my x-intercept is there at negative 6, and my y-intercept is now at 2. Okay, so that's going to be somewhere over there. And again, I want to grab a straight line, a ruler, and I'm going to connect my dots. Okay, so that's the idea. Just click on this guy. Okay, I just want to make it longer. There we go. Okay, that's what you're supposed to be doing when you draw. And then your line, y equals x, would go through the origin. Whoopsie daisy. Let's just correct that. There, like so. Okay, there would be the line y equals x. Correct. Exactly, Nosipo. So what was your x-intercept is now your y-intercept, and what was your y-intercept is now your x-intercept. Okay, so the only thing that I haven't done is I haven't labeled the 2 over there. Okay, so if I just go down and show you what it looks like over here, right? This would have been B. There it is. Okay, and there are the coordinates at the point of intersection for those of you that managed to work that out. All right, so your original function, Katlego, I will take your question now, no problem. There's your original function, okay? Y and x-intercept. Here is your inverse function over there, all right, in green. And again, here is your line y equals x, your line of reflection. Okay, Katlego, what was your question?
Ma'am, I
Yes.
just wanted to know, ma'am. Okay, so last week I was not here and I haven't watched the video yet, so I'm still going to watch it. So, and just in case the question that I'm about to ask you've already like answered it, but I just wanted to know, ma'am, what is the relationship between these two like functions gradient? If that question makes sense.
Yes, it does. All right. The relationship between these two functions is that the one is the inverse of the other. They're inverses of each other. Right, they're inverse functions. So if we consider the yellow function to be our original function, the green function is the inverse of the other function. So in other words, in order to get the green line, what we've done is we've swapped the x and y coordinates of the yellow line around. So every x coordinate that was originally on the yellow line is now a y coordinate on the green one, and vice versa. Okay, so essentially our x's and our y's have swapped around. That's the relationship between these two. And it's exactly the same as reflecting the yellow line over the pink line to get the green one. Okay, it means exactly the same thing. Does that answer your question?
Ma'am, I wanted to know the relationship between their gradients. Like,
between their
something...
gradients.
Yes,
sorry, between their gradients. Oh, okay, I see what you're saying. Okay, so it's not like perpendicular lines where you can say the product of their gradients is going to be equal to -1. But what you will find, like if the gradient was originally 2, right, then as it was in some cases, then what you would find with the inverse, the gradient is going to be 1/2.
So, ma'am, the gradient is the inverse of like the original. The gradient of the reflected.
It's the reciprocal. Let's put it that way.
Yeah.
It's the reciprocal. It's the reciprocal. Okay, does that make sense? So the gradient is the reciprocal.
Okay, ma'am.
Okay,
Thank you.
all right. Okay, that's fine. Not a problem. Sorry, I'm glad I understood what you were trying to ask me. Sorry about that. Okay, the gradient is the reciprocal. Yes. Okay. Okay, so Lutando, that's a really good question. All right. If we have got y equals x plus 6/3. What I'm doing, remember when we were little in primary school and we wrote something, if I write 1/7 plus 2/7, you know that I can write that as 1 plus 2/7. So in other words, I can split the denominator. The single denominator can be split between the two numerators. That's essentially what we're doing, right? So we're writing that y is equal to x/3 plus 6/3. All right, now if x is divided by 3, that is the same thing as taking 1/3 of x. Okay, so dividing by 3 or timesing by 1/3 is going to be the same thing. And then if 6 divided by 3, that's where the plus 2 would come from. Okay. All right, yes, Sihawu, not a problem. Let's go down and go and have a look at it. I see our time is running out. Let me just make that a little bit bigger. It should have looked like that. Okay, so that's what that should have looked like. Are there any questions about E? Pleasure, Lutando. Ola, which question 4? You mean, are you talking about the coordinates at the point of intersection? Okay, so Ola, you would take, so it doesn't matter which of the 3, because remember, at the point of intersection, I'm just going to have to go up again, Sihawu and everybody else that's looking at E. So just take a screenshot of that so that I can go up again. All right, so here's the point of intersection, Ola. Right, at that point of intersection, you've got 3 lines going through there. All right, so you've got y equals 3x minus 6. You've got the line y equals x, and you've got the line y equals 1 over 3x plus 2. So it does not matter which combination of the 2 you use. If you use this one in the middle, it's just going to make life so much easier, all right? But you can use those 2 if you want, right? So in other words, if I take 3x minus 6 and I make it equal to x, look here, I'm going to end up with x, 3x minus x equals positive 6. So 2x would be equal to 6, so x would be equal to 3. That's how I would be able to solve for that. Or if I took 3x minus 6 and I made it equal to 1 over 3x plus 2, I could solve it that way as well. So if I've got this fraction here, Ola, I want to get rid of it. So I'm going to times through by 3. That would leave me with 9x minus 18 equals x plus 6. Collect my x's together, my numbers together. So that leaves me with 2x is equal to, sorry, I'm talking nonsense, 8x is equal to 24. Divide both sides by x, x would still be equal to 3. Can you see that, Ola? Right, and then you just sub into either one of these equations in order to get the corresponding y. So it's just a simultaneous solution. Yeah, so Pinga, exactly what Yolanda is saying to you there. Okay, you get it now. All right, brilliant. Okay, are there any other questions that you guys want to ask about either B or E? Okay, so Pinga, you happy? Is everybody happy? How are you feeling? Are we thumbs up, thumbs down? Are we smiling?
Ma'am.
Yes, Katleho?
Ma'am, can you please explain number E? Like how you found these numbers, ma'am? I can see that you say that we must use the equation of the line, but like, ma'am, I just want to see you do it because like,
Yeah, absolutely. No problem.
Yeah.
All right. So what we've done here, all right, is that we've used an input of -1. So our original function f of x was equal to, f of x is equal to -2x, right? So I chose x to be equal to -1. So now when I subbed in and I worked out what y is equal to, -2 times -1, that gave me 2 as an answer. So that's why I have -1 and 2. That's this point over here, that one there. Okay, and then that just gave me another point in addition to the origin in order to be able to draw that blue line. Okay, so I would have plotted this point over here, my origin over there, and then I would have grabbed, let's grab that blue color, and then I would have grabbed my ruler and I would have drawn my line. Okay, does that make sense to you?
Yes, ma'am, thank you.
Okay, so yeah, as Yolanda was saying, you're just picking a point. Okay, whatever point you want to pick, it doesn't matter. Use -1, use 1. It's just easy. Okay, and then you would get exactly the reverse of that on the other line. So over here, I know that my x becomes my y, and what was my y becomes my x. And then again, I know that it goes to the origin. I know it goes to this point. Grab a ruler. connect the two, and there we go. And then, yeah, just don't forget to label that and to label that one. And of course, your line of your axis of symmetry, your reflection line, sorry, not axis of symmetry, your reflection line is always going to stay as the line y equals x. Okay. All right. All right, so there's some happy faces here.
Yeah, they did really, really well, guys. Well done. And thank you to Chicky.
It's a pleasure. It's a pleasure. Yolanda, I just want to answer a couple more questions. So because we get started, I know it's time to finish.
That's fine.
Bali, when it comes to E, there's not really anything that you can calculate like with the previous one because it goes through the origin. Okay, and Bali, so it's just you're just literally writing down the coordinates. Okay, because these particular graphs intersect at the origin. You can't calculate. I mean, if you wanted to calculate that, you could, but you'd end up making, I mean, if you took minus 2x and you made that equal to x, if you now want to solve for x, can you see you'd have minus 2x minus x equals 0. All right, so in this case over here, you'd still end up with the origin, right? But it's not even necessary to do a calculation for that. Okay, you know that they're going to intersect at the origin. Let's just go down and see if there are any other questions that we didn't. Cabello, the indication of the inverse function. Yes, Cabello. So that is the notation. Okay, that gets used. That is correct. Where to? So, ma'am, when we label the reflection. So, where to? Are you referring to the line y equals x? Okay, so not x equals y, y equals x. Okay, Lutando, that's a pleasure. So this is just one-to-one functions and linear one-to-one functions. So it does get a lot more interesting. And I will certainly get into that in our second, third, and fourth lessons. Okay, all right. It's a pleasure, Nosipo. I'm so glad you enjoyed the lesson. That's wonderful. Pinga? Yes, you can do some homework. All right. This will help you. It's not exactly on inverses, but this will help you with functions. Okay, so you can take a screenshot of that.